Ramesh, we can start the webinar. So it's all yours. Probably we might have few learners join along the way, but
Yeah.
you can go ahead and start.
Okay. All
Thank
right.
you.
Thanks. Thanks, Raj. Appreciate appreciate this opportunity. So, just for everybody, my name is Ramesh Dwarkanath. I am a enterprise solutions architect at AWS. I have been with AWS for slightly over 4.5 years now. And my primary role is to help our enterprise customers with their cloud journey. Uh, what that really means is, I have conversations with our customers, understand what their business problems are, and then translate that to solutions, right? Those could be typically they end up being technical solutions. Or it could be even be organizational solutions or process solution, or we have a wide range of solutions that we offer. And as far as from a technical perspective, we AWS has a whole big portfolio of services, and we pick some of those services depending on what the situation is, and then use that. But it's not necessarily the case every time, right? So it's not like every customer business case or use case is resolved with only AWS services. We use a combination of sometimes third party, because sometimes those third party services might have better capabilities at that point in time. And there are a lot of third party services that run on AWS, so they work very well within the AWS ecosystem. So that's really kind of my job, is to make sure that we have the right solution for the right problem. I Prior to that, I worked with financial services, so I was on the other side of the table, and I was involved with some private cloud offerings and build out of that. And one of the things that kind of hit me when I came into AWS is like the way, the scale, and the ease at which the whole infrastructure is built out, right? Because I was actually involved in building some of that out. I understood firsthand the challenges that were there in actually building the infrastructure out. So I truly appreciated that, and I came here, and I'm like, wow, this is incredible. So again, it's really, AWS is definitely a leader in that space in terms of providing all these different services. Now it's almost like you can build anything and everything, right? There are purpose-built databases or any of these other bunch of other services that are available through AWS. So one aspect today that we are going to talk about is DevOps. DevOps is a term that has become very popular nowadays, and then again, different everybody's using it, and especially in the cloud world, when you're trying to get on, DevOps is a fundamental aspect of that. So we're going to talk about the DevOps services that are offered, or DevOps on AWS. And what does that mean on AWS? So with that, so that's really kind of the the session for the next hour or so, and we'll go through what are all the concepts behind it, and what are the different services that AWS provides in the DevOps space. All right. With that, what I will do is let me share my screen. So can you see my screen?
Yes.
Yes, I can.
Yes. Yeah.
All right. Great. All right. Cool. So what I want to talk about today is really the DevOps on AWS. So at a high level, this is the agenda we'll cover. We'll talk about what is DevOps, right? What is the definition? Um, how does Amazon use DevOps, right? So it was not like Amazon was always using DevOps, right? So we learned on our own, and we're using that experience to educate our customers and help other users and customers. But then we talk about the AWS code services, which is essentially all the services related to the code deployment, building, delivery, and so on. So we'll walk through the aspect, and then we'll also talk about the DevOps portfolio, right? So it's not just the code deployment. It's not just like continuous integration, continuous deployment, and we'll go through the CI/CD. These are all terminologies that you will hear in the context of DevOps. But there's also things like monitoring, configuration management, and so on, right? So we'll cover, those aspects also as part of the DevOps portfolio. So from a definition of a DevOps, right? So there are essentially three main buckets that it falls into, right? So there's the whole philosophy aspect of it. What does that, what are what does it really mean, right? And it's not just tools, right? It's not just I used this tool, I used that tool, and that's why I'm doing DevOps. No, it's really a cultural thing, right? What does that mean to an organization to be DevOps? Then we talk about some of the practices. What goes into that? What really means when you say you're implementing or you're implementing DevOps in your organization? And then finally, we'll talk about the actual tools that are used to help with that implementation. So DevOps is, just as the word says, right? It's the development and the operations coming together, right? So no more silos. Now, depending on what organizations that you have typically worked in, whether it's big or small, really doesn't matter. But in the past, it's always been the case that there's unless it's a very small organization and there are not enough people, but for any medium to big size organization, you would have like a development group, and then you have an operations group, right? The developers would actually build the code and the application, and then pretty much just throw it over the wall to the operations group now, who would be responsible for its day-to-day management, maintenance, and alerting, monitoring, escalations, and so on, right? And that's what typically used to happen, and even today in bigger some of the organizations it still happens, right? Now that always had there was always a problem, right? Because there was always a conflict between the development organization and the operations organization. The developers were just looking to put functionality in. They just wanted to get it out the door quickly and just do some level of testing possibly, but then really not covering everything, and then just giving to the ops group. And the ops group basically just now was left with that application, and now they had to productionize it, make sure that it's scaled, make sure that there was no issues with it, there was no outage, and so on. But then they were not really the developers, right? So they didn't necessarily know the whole code and all that stuff, but they understood the non-functional requirements. They understood what are the requirements of their end users, and how much power do they need, what kind of traffic should it support, and so on. Whereas the developers really understood the underlying code, but they didn't necessarily understand, right, who were the end users, and they were not exposed to that. So there was a disconnect there between the two, right? So the whole concept behind DevOps is to kind of break those silos down, break those walls, and create this whole shared responsibility, right? And along with that comes obviously the ownership and the visibility and communication. Right? So the moment you break down the wall, now both the ops teams and the development teams are responsible for that code. It's not just building out the code, but it's also the day two aspect of it, which is really management and maintenance of the code. And there is a sense of ownership, right? So now, there is, the ops people get involved with the developers to understand the code itself, and probably are involved with some aspects of the development itself. And on the flip side, the developers are actually now a lot more exposed to the operations aspect of it, and able to figure out, what the challenges are from an operations perspective, and then to be able to code it accordingly, right? So there is the joint ownership aspect of it, and then finally there is visibility and communication, right? So it's not like only the ops teams are getting paged on it, or they are the ones who have to deal with it. Now it becomes a collective effort between both the developers and the operations group to kind of take ownership of that problem, and then help resolve the problem, right? So as you can see, when you get into this DevOps model, it's a lot more efficient, right? It gets you into a lot more quicker way. You have all the right people who are trying to solve the problem, so it gets the issues get resolved much quicker and faster, and there's not as much friction because now everybody has a stake in the game, right? So now it's everybody's interest that everything works out good, quick, and is as stable as possible, right? So coming to the DevOps practices, right? So these are all some of the practices that kind of underlying the DevOps concept, right? So the first, and from an application perspective, is really the concept of microservices, right? So you have this monolith application, which is this one giant application that has everything, all the code in it, right? And that's how traditionally it was built out, and it's the quickest way to build it out, right? But it is not manageable. It is not maintainable easily, right? Because any change you have to do, now you have to not only update the whole code base, but you also have to test out every aspect of it, whether that code has changed or not. And then sometimes you just you cannot really fully understand what the impact of your code changes for the rest of the code, right? And you could potentially break something. So there are those challenges with the monolith application. So the solution for that is really kind of moving into microservices. Microservices is breaking up the functionality into smaller standalone pieces that can sustain and on its own, that is managed on its own. You have now smaller pieces of functionality that can exist on its own, and the way they all come together as one application is really talking to each other over a common language, right? So they have these APIs, standard interfaces that use to communicate between each of these microservices. So there's like a shopping cart application is a good classic example where you have somebody who is putting in the order, and that's a microservice by itself, and then somebody else is updating the order, that's another microservice. Where somebody is the UI aspect of it, actually showing the results of it, tracking it. So these are all like different components that used to be typically one big application, now can be broken up. So the advantage of breaking up something like this is it can all be managed by itself, right, independently of each other, as long as the interfaces to the outside world is consistent and common, right? You can do whatever you want within your own application. So it improves agility, it improves speed of delivery, right? And then you don't have to necessarily, and even from a testing perspective, you're just testing your own piece, right? As long as the interfaces are consistent, right? What data you get in, what data you get out of that service is consistent. You really don't have to worry about testing out all other application, the rest of the application, right? You're just concerned about your own piece of it. CI/CD, which is continuous integration and continuous delivery or deployment, right, is another critical component of DevOps, right? As the figure shows here, you have your source control, where you're putting in your changes, and then you have your build, where you're running your build and unit tests. That goes into staging. Now you're putting it into like a UAT or a QA environment or a staging environment, and then finally you deploy that final code into production. So that's kind of the whole cycle, right? Those are all the different phases. But what continuous integration is really kind of integrating the source code changes all the time into and doing a build on it, right? So you're constantly creating updates, versions, whatever, and then constantly building it. That's your continuous integration, or integrating the new code. And then you have delivery, right? So which is basically you're continuously delivering that code all the way through to production with some sort of gating factor, right? With like some sort of an approval to say, okay, hey, somebody signs off and saying, okay, this code is good, and then it moves into production. And then finally, you have your continuous deployment is like whatever has been approved for delivery, is now deployed onto production, right? And it's all under the covers. It's all automated. There's no, all of this used to be manual, right? But one of the key pieces of DevOps is to kind of really to automate the whole thing. So now, as you can see, right, the whole pipeline is now automated. Everything is in the moment somebody makes a change, it gets updated into the main source code and then the code base, and that's built. The new version gets built out. It is tested, goes through a unit testing, and then it's deployed into production. Right? All of this happens. So your speed of delivery, your turnaround, in terms of the turnaround time, in terms of the changes itself, gets speeded up dramatically, right, based on what it was in the past. The third piece is the infrastructure as code. This is actually a very, very critical piece of component of DevOps. Is you want to make sure that everything that your infrastructure is also treated as code. Right. So essentially what you have instead of, now building out your infrastructure as like separate physical servers and so on, right? You are abstracting that at a layer, at a software layer, which is essentially you're writing it code, like in this case, like JSON files, for example, in AWS, that which describes, like an EC2 instance, for example, right? So that's your virtual instance that you would spin up in AWS, right? You're just using it to describe it, like, hey, this is my size, this is the amount of memory I want, this is the kind of networking I want, and all of that. And that under the covers gets translated into an actual server, right? Into an actual creation of a physical server. So this infrastructure as code is a very, very powerful aspect, right? Of the whole DevOps practice, where now this is code, right? At the end of the day, this is a JSON file. This is a file that you have that you can actually version control it. You can do, updates to it. You can, store it into a source code. So you just manage it just like you were manage using just like your source code, right? Your application code, for example. And the whole advantage of doing something like this is it becomes consistent, right? It is automated, it is consistent. So when you build out, whether you build one EC2 instance or virtual instance, or you build 1,000, it doesn't matter. It's exactly the same, right? That has always been a challenge in the past, because now you've taken, in the past, where things were built out more like on a manual basis separately. So they're always like, whenever you do anything manual, anything, any human involvement gets there, right? There's always nuances. There are always changes potentially from one person to another. And that's how, like, your one instance might look like, what doesn't look like the other one, right? There might be a small change, but that goes away when you change into infrastructure as code. And then you have the final one is the monitoring and logging. This is another key aspect, where now that you have everything automated, everything is done in a rapid fashion, right? You need to be able to monitor and analyze your metrics, right? Becomes even more critical. right? There is no human intervention, or there is, there nobody's watching it, nobody's actually doing it physically themselves. It's all getting done in an automated manner. But if something goes wrong, right, you need to be able to get at it very quickly. Right. And that's really where your monitoring and logging comes in, that you track that whole application, and you're able to understand your real-time performance of the not just the infrastructure, but also of the application. So that way you kind of have a good idea of what the baseline looks like, and if something is going wrong, you're able to track that a lot more effectively and much more faster, right? So monitoring and logging kind of form that whole backbone of managing the overall, looking at the overall application and the infrastructure, and to be able to alert based on your metrics that you have created. Some of the benefits of DevOps, which you already talked about, is obviously the improved collaboration, the rapid delivery, the reliability, right? Again, consistency is very key there. Security, again, security is something that is built in. It's very important. So things like, now there is another term called DevSecOps, which is really, adding security into the DevOps itself, into the whole pipeline. So you have now, so security is no longer kind of an afterthought of this, but it's more like integrated into the DevOps pipeline itself. And then you have scale, obviously, as we talked about, right? I mean, you can scale this out like as much as quickly as possible, because again, there is no manual intervention, there is no person doing it, so it's really not gated in any way. It's all software. And then finally speed, which we already discussed. So we're having talked about some of these concepts, right? Let's go take a look at how Amazon did it, right, for its own development. So again, we talked about the whole monolith to microservices concept, right? So in 2001, Amazon developments were happening through like a monolith application, and it was hard, it was tough, right? I mean, the application was growing and growing, and there were a lot more, people coming in and using Amazon.com, and so you had to do something to make it rapid, make it so that way you're not like compiling the whole code, even if you're just changing one piece somewhere. It's like you're compiling. You can just imagine, if you're recompiling or building and testing all of Amazon.com code every time a change happens. I mean, that's just not a scalable option, right? So by 2009, we had these microservices. We had broken down the whole application into these smaller components, and basically we had this what is called as two pizza teams, right? So two pizza team is nothing but the size of a team which can be fed with two pizzas, right? That's really how you kind of have a rule of thumb there in terms of what the size of a team should be, which owns the end-to-end, right? The development, the management, and the ongoing maintenance of that component is managed by that two pizza team, right? So you own it, you deal with the whole thing, like end-to-end. So again, at Amazon, we are constantly looking at improvements, right, on our current process. So we just don't sit on our laurels and just wait, and we just constantly being proactive about it, trying to make sure that whatever we have deployed is better, is good. How can we make it more better, right? So we are a very, very much data oriented company, right? So we do everything based on data. It's not anybody's hunch, gut feels, and all that stuff. It is all based on hard data. So we collected some data on the inefficiencies, right? So what we found was there was a lot of waiting period, right? So we write code, then we wait, then we build code, then we wait, and deploy to code, and then we wait, right? So at every stage there was wait, and overall, if you were to take a look at the amount of time that was being spent or being wasted in just waiting was like hours, right? So the actual writing code or the building code, the deploy code, the deploy to prod code itself was a lot more quicker, but everything was gated, right, in that manner. So what we had to do was like, okay, yeah, you write your code and you build it out, and then you wait for it to be deployed again to be tested. And so there was a lot of areas where there was some manual intervention, where there was the whole deployment process itself was not as automated as we would have wanted it to be. right? So our next goal really was to kind of build tools, right, to automate our whole software release process itself, because that's where we found that the development itself, by changing into microservices and some of those changes that we talked about, you know became really efficient, right? But the software release process itself did not keep up, right? So we had to make some changes, and we had to add some tools to actually automate that aspect of it. So one of the concept around that was pipelines, right? So these are automated actions and transitions, and we'll take a look at that in more detail in the future slides. But basically, from your check-in of the code to the final deployment to production, it's all automated, it's all controlled, it's all managed and monitored and all that stuff. So the advantage obviously becomes it becomes a lot more faster, it's a lot more safer, because you're now looking at it and in doing it in a parallel way, but you're managing and maintaining each of those changes in its own pipeline, right? So and then you can visualize that whole process, and again we'll take a look at some of those aspects in the later slides. So at the end, that's how does Amazon do DevOps, right? They have decomposing for the agility, right? We talked about the two pizza teams. We talked about microservices, right? Automate everything. That is one of the fundamental concept, right? So whether it is infrastructure as code, whether it is the software release process, whether it is the deployment process, whether it's the build process, whatever the case might be, everything should be automated, right? So that is the key. Standardized tools, right? So it's okay to use multiple tools, but you need to have some level of standardization for those tools, right? So you need to be able to take those tools, and then you cannot have, like, everybody cannot have their own tool, and everybody cannot. It's just not efficient, right? So you standardize some tools, then you have these governance and templates, right? So you have, and those are again some of those added aspects where you have these templates for building out this environment, or you have the security and these aspects that are controlled, that are put in that in an automated manner, and this is what you should do to kind of put some guardrails around your environment and so on, right? So that's another, everything is again part of the scripting, part of the automation. It's all code, right? But these are pieces that we put in, and finally, obviously, all of this we're dealing with as infrastructure as code, right? Nothing physical. We're not necessarily racking and stacking servers and so on and so forth. But we are taking it and then putting it in as code, right? And we took a look at that, and we'll talk about that a little bit in the future slide also. Right. So now we've talked about all of this. We talked about DevOps. We talked about the principles. We talked about how AWS, or Amazon does that. Right now, where do you start, right? As an end user, as an organization, right? Where do you start? So everybody's familiar with the major phases of release and monitor. You have your source, and where you're building out your source code. Then you have your build. You're checking in your source code that you've written, and then you have your build, where you're building that source code. Then you're putting that in test. You're testing it out with functional testing, non-functional testing. Then finally you're deploying it in some sort of a staging environment or a QA or whatever, and then finally into production, and then overall you're monitoring the whole environment, right? So again, just to kind of reiterate, so you have these check-in as source code, just like .java files or Python or whatever the case might be. You're doing like peer reviews of new code. These are all standard development methodologies, right, that people do in any development organization or a group. Build is again compiling code. You do unit tests, right? So you do, like, every developer will test his own piece of code, and whether it is some sort of stubbing of the other code or whatever the case might be, but you're basically doing your own pieces. And then if you are looking at containers, right, and that's another whole other topic that we talk about, like the Docker containers, where you can, if you have different application dependencies and so on, and custom dependencies, you can package all of that stuff in a container, which is kind of a self-contained module of all the application dependencies that it needs to run, right? So again, I won't go into too much of details talking about containers and this, but just suffices to say that as part of this build process, also you can actually create an image that you can create a container of. Testing, again, integration tests, right? So you did the unit test, but now you're integrating with other systems, other applications, other pieces, and making sure everything works fine. Penetration testing, security testing, all of that is included in this. And then finally you deploy to different environments, including production, right? So once the testing is all over, then you're satisfied, and then based on an approval, then you deploy it onto production. And then finally you have your monitoring that's happening in the production environment, where you're detecting unusual activity or errors really quickly, right? So from a the terminology point of view, right? So we talked about that. We touched upon that briefly earlier. So continuous integration is essentially taking the source and build, right? And continuously, you're checking in the source, and then you're putting into build, and then you're integrating that source code, new source code, into the main application code that you already have. So that's happening on a continuous basis. So that's called continuous integration. Then you have continuous delivery, right? With which goes all the way to deliver that code itself, all the way to production, right? With a gated, with a manual approval potentially in between, to say, is this code ready for to be delivered to production. And then finally you have your deployment, which is essentially now whatever code was delivered, right? Now you're deploying it actually onto the environments, onto the different environments, including production, right? So that's kind of a rehash of some of those terminologies that we looked at. CI/CD, that's how it's typically referred to, right? So if you hear that term, that's what that means. And then you have your, walking through some of these specific tools, services that AWS has. You have your source, which is like an AWS code commit, right? We'll talk about that a little bit more in detail, each of these services. Then for build, we have something called as AWS code build. For test, we can use code build itself, build our own, functionality testing or third-party integration testing, or we can use some other third-party tools, right, to help with that. And then you have your code deploy, which is another service, and then X-Ray and CloudWatch, which is our X-Ray is the distributed tracing and monitoring application service, and CloudWatch is our central monitoring service, right? So, one of the things that you'll see is all of these are managed services. What that essentially means is you as end user really don't have to worry about whether that service scales or, highly resilient and available and so on. All of that, being a managed service, is handled by AWS under the covers. Yeah, and combining all of those, whether it's the source, build, the code commit, code build, all of these are various, services that we just talked about. You put all of that together, and that's your AWS code pipeline. And there's something also called as AWS Code Star, which is essentially, encompasses everything, including, code building and deploying, and then actually, putting it into production and actually starting to monitor it. All of that is encompassed within Code Star itself. So you have these templates already formed for these type of applications. Whether it's a Node.js application, Java application, whatever, you can use CodeStar to kind of use some of those pre-built templates to kind of build that end-to-end application, right? With code pipeline and all these other pieces under below that, those are all the pieces that are under the cover, right? That are used, but CodeStar essentially is abstracting a lot of that and giving you a full end-to-end deployment, way of deploying and managing the application itself. The DevOps portfolio. So from a development point of view, from a delivery point of view, on the left side, on the first one, you have the code commit, code star, code build, code deploy, code pipeline. Again, we talked about that. Those are all dealing with the actual build and source and testing and all of those, the software release process itself. Then you have the infrastructure as code, right? So you have the CloudFormation, which is the native AWS service, right? And that's the JSON files that we looked at, which are essentially the files that get translated into actual infrastructure under the covers. Then you have AWS OpsWorks, which is for Puppet. So OpsWorks is our managed service where we use it for managing Chef and Puppet, right? So those are two infrastructure management tools, right? Infrastructure and configuration management tools, open source tools, very popular. We have a managed service for that, so which means you can use the tool as is, right? Those tools, but we will actually manage the infrastructure for you. So that's the kind of the best of both worlds, right? So if you already are using Chef or Puppet in your organization, you can just use OpsWorks and actually, and let AWS manage the infrastructure, for that for the tool itself. And then finally, you have monitoring and logging. You talked about X-Ray, which is a distributed tracing and monitoring system, so you can track a transaction across multiple areas, like, whether it goes into a web server, an application server, to a database server. You can actually track the whole transaction, figure out its latencies, figure it out its where it is spending more time and what's the flow, and so on. CloudWatch is a core monitoring tool where you can get where it provides logs, it provides metrics. You can alarm on those metrics, so you can do there's a lot of functionality in CloudWatch. CloudTrail is your auditing tool. So essentially everything in AWS is an API call. So all of these API calls are tracked through CloudTrail. So you can when you enable CloudTrail, you can figure out who did what, when, where, and why, and all of those things are tracked within CloudTrail. So that's what you need to. That's a best practice to enable that, and then you have automatically you have all the auditing available for any kind of auditors that come in. And then finally, you have AWS Config, which is our configuration management tool, which actually tracks changes from a baseline information. So if you have, you set up a baseline, then any changes that happen relative to that is tracked by config, and you can get alarmed on it, and you can take, automated actions on it, or whatever the case might be, or you can just get alerted. But that actually tracks over a period of time, right? What changes happen. CDK, Cloud Development Kit, is more of a developer kit, which abstracts the whole cloud formation, the infrastructure as code piece for you. So what it does is it has support for JavaScript, TypeScript, and Java, and a couple of other languages, and you can actually create, like, just like you're writing your code, you can just say, hey, I want to say create VPC, create EC2, create DynamoDB, and that's all you have to do as a function, as a call in your application code itself. And what that does is that call is taken by the CDK CLI under the covers, and then it is converted into the actual CloudFormation JSON template under the covers, which in turn is used to deploy the actual infrastructure itself, right? So it's a very powerful tool for developers, because now they don't have to necessarily worry about all the details and build out separate, like, CloudFormation templates and so on. All they can do is just call this function, and that gets translated under the covers into the CloudFormation template. So very, very powerful tool for developers to integrate infrastructure into their code itself. So building and testing your application, we'll just quickly go through some of these services that we have. So we have the AWS Code Build we talked about. It's essentially a building service that you can use, a build tool that is used to build out your applications. And again, it's a managed service. You only pay for what you use and what you consume, and then it can be introduced. It can be used to deploy Docker containers or Docker images, right? To build out Docker images, rather. So, just a quick thing about how it works. It downloads the source code, it executes the command build in the build spec file, and we'll take a quick look at what that spec file looks like. And then it basically streams the output, the build output. You can actually see it on the console itself or the CloudWatch logs. And then finally, whatever the artifact is, whether it's a jar file for Java or some other file or a Docker container or a container image, all of that is stored in an S3 bucket. So again, with how can you integrate with, how can you automate your release process so you can integrate that with either code pipeline, for example, or you can, it's easy. Again, everything is API, CLI driven, so you can use that. You can bring your own build environments, right? So again, we talked about the customized environment, so you can build actually like your containers or your Docker images with those customized environments, so that way you don't have any dependencies. You can put all of those dependencies in a self-container in a self-contained environment like a container. It has integrations with third-party tools. Jenkins is a very very popular build tool, right? So we have plugins that work with a Jenkins master, for example, from a Jenkins. So if you're already using Jenkins, you can just call code build right from there. This is an example of a build spec YAML. I won't go through much detail, but suffice it to say there is this concept of phases where you have these install commands, and then you can do some pre-build stuff. You can do post-build stuff. You can do, build itself is the command, and then finally the artifacts, right? So you can, do, install different packages. You can do as part of your pre-build, for example, or the install itself, and then you can test your application for the part of the unit testing. You can do that as part of your post build. So these are all the different phases that you have that you can actually leverage and put in your own commands, your own scripts in each of these phases, and then code build will just run this. Just a quick thing in terms of the unit test itself can be done by code build, and third-party testing, third-party tooling is used for service-based or the UI. We don't have any native tools per se, but we can integrate easily with code build. So from a deploying the applications point of view, something similar like code deploy, you can either deploy it to your Amazon EC2 or on AWS, or you can actually deploy it to on-premises servers also, right? So that's one of the key advantages or of using code deploys. It doesn't matter whether if the infrastructure is running on AWS or not. You can actually do it on your on-prem. With all other, just like any other service, it integrates with your third-party tools and other AWS native services. AppSpec.yaml file is similar to how you saw in the buildspec.yaml file, but in this case, it's purely for deployment. And here, just like you had for phases in buildspec.yaml, what you have here is hooks. And again, it's all kind of sections where you can put in your own scripts to figure out, okay, now you want to stop the application, but then stopping the application maybe also means that, okay, I need to take that instance away out of the load balancing, because otherwise load balancer will keep saying it's not available and so on. So that's part of your scripting. You can do whatever the install dependencies are that you need for the application. You can actually have those deployed. Stop and start your like a web server, for example, Apache or whatever, and then finally you can run some post scripts to do actually testing, and then and then re-register it back with ELB, right? So once the new code is deployed, everything is working fine, then you go reattach it to load balancer. That way now traffic starts flowing back from the load balancer. So from a deployment point of view, you have multiple ways of deploying it. So we group these servers into what we call as deployment groups, which could be a development deployment group or a production deployment group. That's one of the way you put everything together. But then you also have, so you can do either one at a time, or you can do like half. You can do half those nodes to be deployed, or you can do all at once, right? So depending on what environment you're in, obviously in production, you don't want to do all at once because you could, it'll result in some level of disruption, right, to the end user. So unless you're doing it in a maintenance window, but typically you could do it half at a time or one at a time. It takes a bit longer, but it's more safer. And then we talk about code pipeline, which is essentially like the whole pipeline which leverages these code build and code deploy and all of these services right under the covers, but then creates this nice framework around the all of these pieces that tie into all of these different pieces, and then give you one common easy way to kind of kick off that whole all of those processes, right? And we'll take a quick look at how that looks like. So this is how a code pipeline looks like. So you have this is the visual representation of it. So you have the source, which could be GitHub, for example. It could be code commit, right? So we talked about code commit, which is the Git version of AWS. It's a managed service, right? The open source version is GitHub. So you could use that as a source. You can obviously use code build as one of the build options, and then finally deploy. You could deploy it either like a Java application, but to an Elastic Beanstalk. An Elastic Beanstalk is another service that kind of is a nice way to kind of deploy your applications quickly and manage and maintain. All of that is by AWS. So again, not I won't go into too much of details on Beanstalk itself, but that's another environment that you can deploy to, right? So that's kind of the whole pipeline, right? So you have your source, your build, your deploy. And then each of these are called stages, right? So these are the build stage, the deploy stage, and within that stage itself, there is the action, right? So which within the build stage, you're actually calling AWS code build, and you're going through the whole build action, right? And then you have the transition, right? So once the build is done, then you're transitioning on to deploy, right? Now the transition is where you could actually potentially put some sort of a manual gate, right? Where you could put like an approval process. And in this case, you can do multiple things. So for example, you could do like parallel things, so what is called as parallel actions, right? So you are building the code. Once the code gets built out, you automatically in parallel deploy, kick off a Lambda function, which is a serverless function, right, to notify the developers, right, to say that hey, the build is done, right? So it's something that is happening in parallel, right? Or you could have sequential actions, right? So like a code build, the build is done, so you're not only like now notifying the builders, but you're also running the test of the unit test, for example, right, on the build, on the code that you just built out, right? That is a sequential. Obviously the code has to be built out before you can actually run the test API, right? And then finally, of course, you would deploy onto that, right? And this is the manual approval which we talked about, where essentially when you have deployed it, now you're talking about, okay, now you did a staging deploy, right? And now you're done all your testing and all that stuff, and then somebody comes in and pushes a button to say, okay, yeah, ready to go, right? And at that point, once that approval is received, that's when the transition happens to production, and that's when the prod deploy happens, right? And so essentially that's kind of your end to end. And this is exactly how if you go into the console, when you look at the code pipeline, you will see that this is exactly how it is shown there also. So it's a nice visual representation of how the different stages are laid out, how your application is progressing, and if there is an error, it kicks off in any of these stages, and then it won't go to the next transition, right? So the next transition won't happen until the error is fixed, right? So that's a nice way to look at that. Code commit, again, it's it's just like GitHub, for example. It's a managed Git source control, uses Git tools. Again, encryption at rest, right? So all the data that is stored, all your source code is all encrypted. The S3 is your under the covers storage mechanism, right? And when we all know that S3 is highly durable, available, and scalable, right? So that's code commit is supported or under the covers by S3, so that all the data will be safe and available to you. Source, again, just a quick thing about the managed service, about code commit itself: security, fully managed, highly available, store anything, right? And again, there is no real in terms of the amount of source code you can store, the type of source code you can store. There really is no limitations per se. So this is how you would, typically you're on your laptop and you can access your source code through either SSH or HTTPS. Just like anybody who's done this with like a GitHub, for example, you would get the same thing with code commit, exactly the same functionality. And under the covers, code commit is actually storing the objects in S3. It's the index is stored in DynamoDB so that it can quickly reference from look at DynamoDB and get access to the actual object itself in S3, and then it's all encrypted using in KMS, which is our key management service. Using that, all those objects are encrypted, right? So it's all safe. Some example, I mean, this is something, if you have worked with Git commands before, you would clone your repo onto your local environment, and whatever after the changes that you do, you can actually commit to it and then push it up, right? So the same commands, identical, no difference at all. With whether you're dealing with like a GitHub, you do exactly the same thing with code commit also. CodeStar, again, we briefly touched upon that. It is to give you an end-to-end, not just the software release process right from source code, but also the deployment of it, and then the actual running of it, and then finally you have your so that way you can actually build your applications a lot more faster, a lot more quicker. Like I said, there are a lot of these templates that are available, and once you go to look for CodeStar and go to the go to that page, you can actually see there are a bunch of those templates available, and you can actually, so if you want to build it in Node.js, or if you're looking to build an application in Python or Java or whatever, you don't have to start from scratch. You have these templates and you can just quickly get going and build your application a lot faster. We talked about X-Ray. So X-Ray is essentially, what it does is, it is tracing the requests made to your application, right, end to end. So there are, collects the data, whether it's coming through the web server, the application server, or the database server. It's basically collecting information all across. You're putting all of that together in what we call as, units called traces, right? And then those traces, and then you can actually see those traces, right? In a UI, right? So where you can actually, the two things. One is the rightmost, which shows that green and red circle. I mean, that's really what it is saying, is that certain transactions are green, and this is what your everything looks good, but then the red ones are are having a problem. You click on that and it actually takes you to the actual the transaction itself, to say maybe the application might be showing slowness, but then you dig into it, then you say, oh, okay, it's a database, right, which is a problem, and it's just taking a lot more time, and then you click on that. It's like what in the database is causing that slowness, right? So you can actually dig in very quickly from the top into the actual specific problem. So it's a very, very powerful and useful tool, especially in the world of distributed applications, right? So there are so many different components that are in play, right? So it's very hard to if there's somebody says, hey, the application is slow, right? Somebody just end user comes to you to go from there to actually figure out and dive deep and figure out exactly which component is having a problem. This is a perfect service for that. Right. And then you also have this concept of service map. Service map is like, how is your application laid out, right? What component talks to what other pieces, and it's all laid out in a visual manner, right? So it's really, really neat, very nice, because now you can know that, okay, there might be 20 components, right? But then I know exactly how each component is talking to each other component. Right. So that way, when you are tracing a problem, right, you're not chasing something, which is not even in the picture, right? So unless you know visually how the application is flowing, it's very hard to do that, right? So this tool actually helps you with kind of documenting and putting that visual map, called a service map for it. So here there are a couple of concepts here. But this is a kind of a good diagram to talk about, whether it is an on-premise server or it's your AWS, instance or a EC2 instance or your containers or your Lambda or whatever. That all of that get fed into AWS into X-Ray, and then you can view all of that in the X-Ray console itself, right? Visually, you can see everything, regardless of where the where the problem is, or where the application is residing, right? And this is like a hybrid application in this particular case, right? So there are certain pieces of the application that are running on premises. There are certain other pieces that are running on AWS, right? It doesn't matter. The console will give you the nice big, holistic picture of all of that. The X-Ray SDK, which we refer to in the in the previous diagram, like we look at the app and X-Ray SDK, right? So that is essentially what it is doing, is that X-Ray SDK is capturing the metadata, for calls that is making it to the other AWS services, or the calls that they're making over HTTP and HTTPS to non-AWS services, calls that they're making to the database and the queues, and this is how it's basically tracking it, right? So it's able to get access to that metadata, and you really don't have to instrument your application code. That's really what the neat part about that is, because what it is doing is capturing that metadata is really what it is doing to capture the whole transaction end to end. So really, you're not updating your application, you're not doing adding anything logic to your application or whatever. All it is doing is like the SDK is taking care of that. The X-ray daemon is that intermediate piece, that's basically collecting the data from your application, from your instance and all that, and moving it over, pushing it into X-ray, right? So where everything is being collected, and then everything is is being analyzed, right? So the collection is the daemon is really comes into play for the collection piece of it. So as you can see, it is supported for Linux, AMI, like Red Hat and Ubuntu and Windows. With AWS Lambda, it actually comes pre-installed, right? So that's what it is, and you, again, it's all protected, whether it is your own AWS credentials or you have your EC2 on your on-premise environment, or maybe your EC2 role, which is essentially temporary credentials. It's all protected, right? Information. And then you have your Cloud9 environment, which is an IDE, which is your development environment, which is all in the cloud, right? So you don't have to download anything onto your laptop or your PC or whatever. You can actually leverage this on AWS itself. And the advantage of this is it's all integrated with all the other AWS services. So if you develop some code, that actually gets automatically integrated well with other AWS services. So this is a very powerful tool. You should definitely take a look at that. And this is how the UI looks like. It's actually pretty, pretty robust, pretty good. Just a quick thing about how this end-to-end works for like a serverless application. Serverless application is essentially Lambda, which is like you're not managing any servers, anything. All you're doing is just taking the source code itself, right? And what this does is basically taking it, and this is talking about end to end, like you're authoring the code in Cloud9, putting it into code commit or GitHub, and then building it and deploying it on Lambda, right? And it's all managed through code pipeline. And monitored through CloudWatch. So this is one example, right? Or X-Ray, for example. The other one is for containers. So we talked about containers quite a bit, and in this particular case, you're putting the code into AWS, code commit or GitHub. That's getting built by Code Build or Jenkins, for example, right? Managed again through code pipeline. In this case, we are actually putting the image itself into ECR, which is the repository, our image repository. And then ECS is our container orchestration system called Elastic Container Service that is actually pulling that source code from ECR and then getting deployed onto the Docker containers are getting deployed on ECS. So that's essentially what the end-to-end is. This is one of the other, classic applications and using containers and how you would use source code. the whole the code pipeline and code commit and so on. Just wanted to give you a quick examples of how it's used in a serverless for Lambda or containers using ECS. Right. So we are at the top of the hour. I know I went through a lot of content here, but hopefully, I think there were some things that that caught your attention, and you would be able to follow up on that. Again, a lot of tools available on DevOps on AWS, and hopefully you'll get to use them and play with them. With that, thank you for attending the session.
Thank you.
Yeah, thank you. Thank you, Ramesh.
Thank you.
Yeah, thanks for that.
Thanks,
Thank
Ramesh.
you. Thank you very
Thanks,
much. It's
everyone,
been
for
a
joining.
wonderful presentation.
Great.
Definitely
Thank you. I
learned a lot.
appreciate that. Yeah.